Hello, and welcome to this introductory video on charge. In this video, we're just going to introduce very generally what is electric charge, and then we'll explore all of its various applications in subsequent videos with some details filled in, but we'll introduce it here. To set that introduction in motion, let's think about objects just in everyday sense. What are some of their basic properties? And some of these things, I mean, like color or its size, and they're obviously important properties depending on the discussion that you're actually having. In terms of physics, though, we know that one of the most fundamental and most important properties of an object is its mass. And we know this because we just need to look at, say, Newton's second law, F equals ma. That mass is very important. It determines, if you apply some force F, what acceleration is going to be a result of that force for that object given its mass. So mass determines how objects respond to forces. Also, in context of the gravitational force, the mass actually determines what force it is exerting gravitationally on other masses. So mass, clearly very fundamental. The next most fundamental in physics is probably this electric charge. Now, electric charge is in a lot of ways similar to mass. Electric charge is going to determine how our objects generate and interact electrically or via an electric field and electrodynamic forces with other charged objects. But unlike mass, which only is ever positive, electric charge can be both positive or negative. It has that choice. And they're carried by the particles in an atom. So if you think about it, right, atoms have protons and neutrons and electrons. Protons, those are the guys which have positive charge, and the electrons are the ones carrying the negative charge. So that's pretty interesting. There's a consequence of this too. Electrons are fundamental particles. You cannot break them up into anything smaller. And so in nature, you will only ever find that charges are in increments of the charge of an electron. All right. And the charge of an electron, as you see on the slide, is 1.6 times 10 to the negative 19th coulombs. Coulomb is our unit of charge, and it is defined in this way, essentially that the electron has this charge. Okay. Very small charge for one single electron, but of course, most objects, when we are going to be dealing with charge problems, will be looking at having several excess electrons. Now, most things in everyday life, we don't go around asking what is the charge, right? We're dropping bowls and shooting cannonballs and whatever in our various questions. We didn't worry about charge, but that's because it doesn't always come up. You actually have to do something to create an excess charge in an object because most objects are neutral. So these neutral objects, it's not that they don't have electrons or protons. What it does mean is that they have a balance between the protons and the electrons, or a balance between the number of positive charges and the number of negative charges. All right, so that's basically it for our quick introduction to charge. But if you want to think a little bit further about that, maybe start thinking about, I made the statement that the electric charge determines how they're going to interact with each other. We're going to investigate that a little bit in a subsequent video, but start thinking about that and maybe ask yourself, what kind of effects do you think changing the electric charge of an object would have on its interactions with other objects?